Welcome, my friends. In this video, I will begin my discussion of Chapter 3, Analysis of One Quantitative Variable. This video will focus on Section 3.1, the 5-number summary and percentiles. A percentile tells us what percentage of values in a dataset or distribution are at or below a particular value. A common place where percentiles are used is in standardized test scores. If you scored at the 70th percentile, sometimes notated as P70, that doesn't mean that you answered 70% of the questions correctly. What it does mean is that 70% of the individuals who took the test scored at or less than your score. And also that means that 30% of the scores were at or above your score. There are 3 important percentiles that we're going to be focusing on in this class. First, we have the 25th percentile, sometimes called the first quartile, to which 25% of the observations will be below. Then we have the 50th percentile, which is oftentimes called the median, and occasionally Q2. And finally, we have the 75th percentile, called Q3, or the third quartile. And the reason why we call these quartiles is because they split our dataset into 4 quarters. We have the bottom 25% of our data, and then we have Q1. Then we have another 25% of our data, and in the middle we have the median, which is splitting our dataset into 2 halves. And finally, we have the third quartile, which is at the boundary of the 75th percentile. Now let's talk a little bit more about the median. The median is the value in the middle of an ordered dataset. The way that you calculate the median is going to depend on if you have an odd or even number of observations. Think about that for a second. If you have an odd number of observations, such as 3, 5, 7, or 9, there's going to be one single value in the middle. That will be your median. If you have an even number of observations, such as 2, 4, 6, or 8, there's not going to be one single value in the middle. So there's going to be a slightly different process to calculate the median. Let's first focus on when we have an odd number of observations. Here we have the numbers 5, 5, 6, 7, and 12. This dataset is already in order. The median is therefore the value that is directly in the middle, which in this case is 6. 6 is the value in the middle of our dataset, so 6 is the median. Let's look at a dataset where we have an even number of observations. Now we have 5, 5, 6, 7, and 12, just like we had before, but now we have one additional value of 37. Once again, this dataset is already in order. Since we have an even number of values, there's not a single value in the middle. The middle really falls somewhere between 6 and 7. So the way that we find the median in this case, when we have an even number of observations, is to take the mean of the 2 middle values. To find the mean between 6 and 7, we will add those 2 numbers together and divide by 2 to get 6.5. So in this case, the median is 6.5. Note that the inclusion of the outlier of 37 barely changed the median. It changed the median from a 6 to a 6.5. For this reason, sometimes we say that the median is resistant to outliers, meaning that outliers don't really affect the median very much. Now let's focus on finding Q1 and Q3, the first and third quartiles of a dataset. In order to find Q1 and Q3, first find the median. Then we will have 2 halves of our dataset. The median of the bottom half of our dataset will be Q1, and the median of the top half of our dataset will be Q3. Here is a dataset which contains the income in thousands for car salesmen. Since we have 8 observations, which is an even number, the median will be the mean of the 2 middle numbers, which is between 52 and 62, which ends up being 57. Once we found the median, we really have 2 halves of our distribution. We have the bottom half, and we have the top half. To find the first quartile, we just need to find the median of the bottom half of our distribution. Well, since the bottom half contains 4 values, which is an even number, the median of those 4 values is going to be the mean of the 2 middle values, which is going to be the mean between 40 and 45, which is 42.5. So our first quartile is going to be 42.5. The median of the top half is going to be our third quartile, which is going to be between 76 and 82, which is equal to 79. So our third quartile is going to be 79. Now there's something called the 5-number summary, which is a really good way to summarize a data set with 5 numbers. And those 5 numbers are, first of all, the minimum, which in this case is 25, the first quartile, which we found to be 42.5, the median, which is 57, the third quartile, which is equal to 79, and the maximum, which ends up being 181. Note that if there are an odd number of observations, we exclude the median when finding Q1 and Q3. Let's look at an example of that. Here is a dataset containing test scores where we have an odd number of observations. Let's say we are asked to find the 5-number summary. Well, to find the 5-number summary, we need to find the median, the first quartile, and the third quartile. We also need the minimum and the maximum, but those are easily found just by looking at the dataset. So first, let's start by finding the median. Since we have an odd number of values, the median is going to be the single value in the middle of our dataset, which is going to be 85. Then, as the instructions say, if we are finding Q1 and Q3 when we have an odd number of observations, we should exclude the median when finding Q1 and Q3. So now the two halves of our distribution are going to consist of 72, 81, and 84, and 92, 97, and 100. So Q1 is going to be the median of the bottom half, which is going to be 81. And Q3 is going to be the median of the top half, which is going to be 97. We exclude 85 for consideration of finding Q1 and Q3. So altogether, we have our 5-number summary, which is 72, 81, 85, 97, and 100. All right, here's a problem for you to try. You are asked to find the 5-number summary of the following dataset, which contains temperature in Fahrenheit. So go ahead and pause the video and give that a try. All right, that's all I have to talk about in this video, so I will see you in the next one.